Hello, this is Mrs. Ross, and I'm going to be discussing the lab graphing motion, how to do that today. So when you get to this part of your physics class, you're going to click on that, and this shows up. And then when you click on this link right here, you're going to come to a PDF. And let's go ahead and go through this PDF. So in case you're listening to this not in real time, you'll kind of understand what's going on. So it says, in this lab, you will investigate the motion of an object and create a position time graph and a velocity time graph based on your data. So the materials are a stopwatch with lap feature. Frankly, your best bet for that stopwatch would be your phone. And there is a stopwatch or I think it's split time feature. The battery-powered toy car and the wind-up car are both in a blue plastic container on top of my desk in the science lab, so that if you need to do this on a different day, feel free to come get that. It says tape measure or meter stick. My meter sticks are by my sink, but I'll try and put the meter sticks by the blue box so you have everything that you need. A long flat surface. I believe our best bet is to use the hallway. So like the junior high hallway or what have you. So if you need to know when classes are getting out, I can tell you, but it shouldn't take you very long to run these cars and get these times. So it says duct or masking tape. We're going to be using masking tape, and I'll put that by the blue container that has the cars in it. And then it says colored pencils. That's for your graph. So those are the materials that we have, and we have all of those materials available. The procedure is using the tape, mark a starting point and an ending point on the floor. I highly suggest using the lines that are on the floor in the hallway as your starting and ending point. You're going to want a little bit of distance. I'm talking maybe 2 meters or so between each of your positions. Let's see, and you need, it says 3 to 5 positions. It doesn't matter to me if you use 3 or 5. That's up to you, how much time you have and how deep you want to get into the lab. At least 3. So your starting and ending point might be the beginning and end of the hallway, and then you need like at least 3 positions between that. And the more even you make those positions, the better this is going to work for you guys. So if you say take it at every 2 meters, I prefer you do it in meters. That's what the distance is supposed to be in, since we're in a scientific class. And we have meter sticks, so that works just fine. So you're going to place the tape between the starting and ending point at a certain distance, whatever distance you choose. You're going to measure that distance from the starting point to each piece of tape, and you're going to put those right here. So it may be 2 meters, and then the next will be 4 meters, the next will be 6 meters, however you want to do it. And then it says place the battery-powered car behind the starting line, the piece of tape, and turn it on, and at the same time it turns on, start the stopwatch. So you're going to need to do that a few times. Yeah, at least 3 times it says, or 5 trials would be great. Oh, I see. I'm so sorry. I'm looking at this again. So this is the distance. You'll either have 3 or 4 or 5. You can have as little as 3 or as many as 5. But you will have 5 trials, and you're going to need those to do your points on the graph. So each time the car reaches a new piece of tape, press the lap button, be consistent, and then record the times. So what I suggest is that you do a couple of practice runs first. So I have 3 battery-powered cars. One of them has a push button at the top, which is really easy, and the other have switches on the bottom. They're all emergency vehicles. They're adorable, and they have lights that light up. I just can't stand it. So you'll take one of those and just get a feel for how it works. So it says do that 4 to 5 times. It says at least 4. I prefer 5. And then it says to use the wind-up car. The wind-up car, you like drag it backwards, and then you let it go. I'm hoping that it has enough power to go the distance. So so down here we have the battery-powered car, and this PDF is one that you can fill in. So you're welcome to fill this PDF in and turn it in, or I'll have copies of these for you at the live lesson today. So you can also write it and turn it in by email if you need to, if you want to scan it. But you're going to take the average time here. This is average time. And then let's come down here. You'll use the same distances for the wind-up car as you do for the battery-powered car. And here's the averages of times. And then here's our analysis down here. So it says find the average time for each distance. No problem. You add these up, divide by 5. Plot the averages on a position versus time graph. So you can make 2 separate graphs, or you can plot them both on the same graph. So position versus time, let me show you what that looks like. I'm going to kind of do a little drawing here. Let's see if it'll let me draw. Yes, we want space. Oh, here. Okay, so position versus time. So your position, your x, or your distance in meters is going to be on this side. So you know you'll have 1 meter, 2 meter, 3 meters, however many. And yours had better look way more professional than this. Oh, help me. And then this is time in seconds. And this really depends on how your time comes out. You know, if you have 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So this is your position versus time graph. And you can use graph paper. I have some in my, there's a gray, black, dark gray. I call it a tower. It's just it has supplies. It's right outside of my room. There should be some graph paper in that. If there's not, there's some right inside my room and another different supply. Or you can use Excel if you're adept in Excel. Excel makes it a little bit easier, but you don't want to have to learn how to do Excel to do a couple of graphs. So that's completely understandable. So you can use one graph and you can say, all right, this is my battery powered, and then pick a different color, and this is my wind up. It's going to look something like that ish. So let's go back to our, so it says plot the position versus time graph, and we did that. It says calculate how fast each is going by determining the slopes on your position versus time graph. So the way that you do that, you're actually probably going to use this, like your distance and your average. So let me go back here and show you how to do velocity from your velocity from the position versus time graph. Time. So velocity is slope, which is, this formula should look familiar. So for you, your y's are distance. So you're going to take 2 of your distances here, like this distance and this distance right here. And then you'll take the times that go along with that, or the average times that go along with that distance. So we have our d2 minus d1, and then we have our t average 2 minus t average 1, and that'll give you your slope, or your velocity in meters per second. So that's number 3. And then it says plot velocity of each car. Again, you may create 2 separate graphs. Oof. Okay, you're going to need another place here to do velocity. So I might have to do another video for velocity, because what's going to happen is you're going to have to add another column here, and you'll have only 2 velocities. You'll have 1 less velocity than you do distances, because it takes 2 of them. So let's see if I can add velocity. So they want velocity versus time graph. Okay. So that would make this velocity in meters per second, and this is your time. Your time is going to remain the same. Whatever it was for your position graph, it's going to be the same. On the velocity, what you're going to do is on the beautiful, this is so not professional, but so this is distance, and then this is time 1, time 2, time 3, etc. And then you take your average. So to get your velocity, I would add another square, and I don't know where exactly you're going to put that on your PDF. You might want to do this on paper. So if you have 1, 2, 3, if you do 3, you're not going to have a velocity for the first one because you need 2 distances and 2 times to get a velocity. So this is in meters per second, so you could have one here and here, which is probably makes it a better reason for you to do 5 if you can, because I didn't realize you guys were doing a velocity graph. I read it, I did, I don't know what happened. So you won't have one for this, but you'll have velocities for this, and then you'll use this to graph here. And then let's see if it asks you to do the, oh good, you don't have to do the slope of that graph. That's great. And then you have these 2 questions. It says, what do you notice about the slopes of the lines on the position versus time graph? And why are there differences in these lines? So they're asking you why these lines are different. What do you notice? So you're hopefully going to notice that one of them is steeper than the other one. The reason for that is because it goes faster, basically. So hopefully you'll have that. If you don't, then don't. You don't have to make up an answer. You just answer the questions, how your data shows. And then number 2 says, what do you notice about the lines on the velocity versus time graph? What accounts for these differences? So on the velocity versus time graph, again, you're going to have the battery powered, and you're going to have the wind up, because you'll hopefully find that the battery powered is more powerful than the wind up. And then what accounts for these differences? It's whatever accounts for the differences in the slope on the position versus time graph accounts for the differences in the slope in the velocity versus time graph. So I hope that this has helped. I'll go ahead and post this, and if you have any questions, please let me know. Thank you.